Okay, right. Again, sorry about another change for the office hour for today. It will be moved to tomorrow, 12:30 to 2:30. But I can answer your question quickly after class. You can also stay. That'll be fine. Okay, I want to mention 2 points about lab number 3, and that hopefully can clarify some confusion for you. The first thing is about using numeration types. So what do I mean by that? Recall that the file that you use to generate your ETF projects. Remember, there's a file, sorry, I forgot the name, something ui.txt. Okay, that's the file you use to generate your ETF projects. And you might have seen something like this. For example, type level is defined as easy, and also medium, and also hard, right? So that's what I meant by numeration type. You're enumerating easy, medium, and hard to be the members of the type level, right? Similarly, you got another type for direction, right? Direction, which will be east, west, south, and north, right? Okay. That's about the source input file that you use to generate your ETF projects. Of course, once you pass that into your ETF tool that we supply to you, it's going to generate lots of classes over there, right? So now the question is, how do you refer to them? For example, how do I refer to easy? How do I refer to west, right? So far, many of you got very clever solution. Maybe you simply just run a debugger and see what east turned out to be, and then just use that magic number in the debugger, right? That's one way to go. Or if any one of you actually use like something called reverse numeration table. Any one of you use that? Okay, I saw maybe one of you. Maybe you're not here today. Anyway, so I want to mention this is a very easy solution, which we did expect you to check it out a little bit, okay? Here's the deal, okay? So let's talk about one example. One of the classes is called ETF new game, right? And I want you to do the following exercise. For each class, if it has any parent, it will say inherits from certain class over here. We'll start talking about inheritance today, but that one should be quite easy to explore. I want you to go over the inherit path for every ETF command. I'll just go to one of them, ETF new game. You'll find that for this particular class, somehow one of its ancestor class is called ETF type constants. I'm not sure any one of you actually have seen that. For those of you who came to my office hour to actually ask me questions, that's the class I refer you to. It's just one of the classes that's there. Okay? Find that class, and then you will see that in that particular class, okay, I'll write it here. In that particular class, there is a section there called named constants. Okay, simply we got named constants. And guess what? All the members are simply just there. For example, you would say easy of type integer is assigned to, I forgot, maybe 1, depending on the order. But the value for the number itself is not really, does not really matter. But what's so useful here is, since this particular easy belongs to ETF type constant, which is an ancestor class of this class. So that means you can use it directly in your ETF new game. So under your ETF new game class, you also got ETF new game. Sorry, not ETF new game. It's just called new game. And new game over here. And of course, you got some parameter. I believe it's called level, right? It's of type integer. And now what you can do in the body of that, you can say if the level, for example, equals, I can simply refer to easy directly. Why would this work? Because easy is inherited to this particular class. Okay? You can use this for any numeration type that's defined in the source grammar file.
Okay, so for this integer is the type?
The integer is the type because as I said, every numeration type over here, for example here, every numeration type like a level, each of the member is implemented as an integer in ETF. That's why you see the integer there. But it will be a very bad practice if you simply say if level equals 5 or level equals 4. Right? You should never refer to magic number. In this case, just refer to the name constant.
The text file you gave us to generate it, it says it returns a type level. But should it be an integer instead of a level?
No. So it's different level, right? So here we talk about this particular file. So this is from the user's point of view. From the customer's point of view, when they are thinking about level, they will think about easy, medium, and hard. But when you actually implement it in the programming language, the most efficient way, like in Java as well, they also got numeration type. The easiest way to implement it is by using unique constant values to do that. So that's why you got to distinguish between them. All right. Another point I want to mention to you about lab number 3. I'm not sure if how many of you have figured out already, right? In case you got confusion. So this really highlights the importance about abstraction. Okay? Abstraction is really used a lot when you want to talk about design. Abstraction simply means you're going to filter out irrelevant details and keep only those details that are important to you for your purpose. Okay? Let's talk about the maze. And the maze goes, I'll choose a very simple one to demonstrate the idea. Let's say this is the output maze on the console, right? A very easy one, right? Apparently you can see the solution would just go like this, right? Okay. So now there will be certain details about this particular maze. The way we draw that is by using a two-dimensional array, right? 2D array. And then, I'm not sure if you noticed that, what's the coordinates for this particular spot? Should it be 1, 1? 1, 1? Are you sure? If you say that's 1, 1, you may not have started your lab 3 too much yet, I guess. Okay, but that's okay. Well, depending on how you actually set it up, I'm just saying by default, if you actually trace your code, the coordinates they will set up is actually 2, 1. Okay, I'm just trying to say here's 2, 1. Simply because somehow this is considered as row number 1, right? This is row number 2, row number 3, and row number 4, and row number 5. That's how they count, okay? And then when they count the column, so this is column number 1, this is column number 2, this is column number 3, column number 4, and etc. This particular thing here is simply ignored, not counted as a column. Okay, that's actually somehow suggested maybe in the manual. Okay, anyway, so there are certain details that we adopt for the maze drawer, but this kind of detail should not be included when you consider how the maze should work. For example, to calculate the solution. If you work simply at the level of this particular layout for the maze, it's too low level. We want to create some abstraction of it. Okay, so that's really one of the purposes for this particular lab. So what exactly do I mean? Let's say every cell over here has a coordinate. So this will be 2, 1, and this will be 4, 1. So when you move south vertically, you have to increment the row number by 2 rather than 1. Okay? And also this will be 2, 3, and this will be 4, 3, for example, right? So now, if you see the coordinates over here, you want to create some abstraction about how the maze should look like in such a way that it's much easier for you to work with. And the way to do it is by building a graph model for that. Okay? We're going to abstract this as a graph. Okay? So there's a very critical step you want to pick up, right, for any application. So now for the abstraction, it will look like, let's say we have 4 vertices. You can think about each cell is like a vertex. So here we got 2, 1, we got 4, 1, we got 2, 3, and then we got 4, 3. And how do we decide if there should be an edge between them? Exactly, right? So now you can see that, should there be a wall, according to the maze over here, there's not a wall over here. So there should be an edge. And there's not a wall here, so there should also be an edge. Okay, and then there's a wall over here, so there should not be an edge, right? And then over here, there's also a wall, so there should not be an edge. So this is the underlying graph. Having this graph in the light blue here is much easier to work with, and you can apply the list graph implementation you did in the previous 2 labs. Okay? So my point is, when you actually want to implement, for example, the solve, to actually, by using the shortest path algorithm, you don't really want to work at this level here of the 2-dimensional matrix. It's too low level. What you really want to work at is at the graph level. So that's what I meant by abstraction. Okay, just some additional lesson for you, okay, when you think about lab 3. Any questions about this? You know, for 2, 1, 4, 1, etc., I'll rather leave that to office hour because that's something you're supposed to pick up already. I'm just trying to mention that. For those of you who are surprised by 2, 1, 4, 1, 2, 3, 4, 3, etc., speak to me after class. I will show you how you can find it out and prove to you. Okay? That's not the point about here. The point is really about how to go from two-dimensional matrix into the graph. That's an abstraction process we are applying over here. Okay, I think already got another question about design diagram. Okay, for the bound diagram.
So first thing is like how in depth do you want it?
Yes.
You have the graph cluster and then
Yeah.
you have your model cluster. So how do you want the graph cluster versus the model?
Okay, so I'll just tell you some principle. Okay, so remember there was a set of slides about bound diagram. Okay, so it's something I mentioned to you many weeks ago, right? Bound diagram slides. Now is the time to really make sure you finish that. Otherwise, you don't know how to draw bound syntax. Okay, bound diagram slides is on the lectures page since week 1 or week 2, right? It's been there for a while. And then I would say, so there are two kinds of ways you can present each class. One is called a compact view. For example, you can simply say mates drawer. In principle, for classes like a utility classes that we gave to you, you don't really have to show them in detail. They are not so relevant to your design per se. So for those, you can simply choose compact view. Just draw oval shape. Of course, indicate if that's effective or deferred. Okay. And for your own cluster, for example, the model cluster, right? So you might draw a model cluster over here. Let's say model. In that case, maybe you will show some of your classes over here in the so-called like a detail view. In that case, you will show that in a round rectangle shape. Everything is covered in this particular set of slides. It's self-contained. Go over that. Okay, it's going to help you on lab 3. And then for the detail view, for example, you may have a class called mates, or a very poor name would be ETF model. Right? You should really rename that to something meaningful for this particular project. Mates, and then over there you don't have to show every feature. Again, think about the bound diagram like an abstraction of your design, which means you don't have to show every bit of detail. Only choose the one you think that they are important for people to understand your design. Choose just some part of it. And then over here, you can show several features. If you got any class invariant you think we should know about, also put a class invariant here, and etc. And also maybe mates is making use of another class. There's a client-supply relation. You can also show another class, for example, class A, and also put some label here, right, etc. I would say, yeah. So you're saying, okay, if I understand your question correctly. Let's say you're saying, for example, your mates class is maybe using A, maybe in 2 different ways. Maybe using let's say, feature maybe A1 and A2. So now, should you show only one of them or both? Again, it's up to your call. You may decide maybe only A1 is important to show, and then only show A1. Maybe A1 and A2 are both important, then show A1 and A2. Again, it's up to your judgment. Okay? Yeah.
So last thing, say for example, like A's or A or whatever
Yeah.
points back to something in graph cluster.
Mhm.
So, or vertex
Yeah.
or things, but we want an arrow pointing back there.
Yes, correct. For example, let's say what Ori was asking was like this. You got another cluster according to the menu. You got another cluster over here called graph, right? Where you should really turn off the assertion checking. Let's say, for example, maybe for your class A, somehow it's referring to some of the class over here. For example, you may refer to edge, for example. In that case, you may show the edge maybe in the compact view and then show the client supplier. Whether you should show it or not depends on whether you judge that to be important for your design. Okay? At the end of the day, when the TA sees your diagram, they should have a fairly clear view about how you design your classes together. Okay? Any questions about this? If no, you can ask me after class to clarify any of the things I said about lab 3, especially about the coordinates, right? If you want to know about it, speak to me. Okay, I want to go for inheritance. Before I go for that, let me just talk about, all of you took 2030 before, Advanced Object-Oriented Programming. But today, we're going to do something a little bit different from 2030. 2030, we basically, well, unless you took it with me. Usually, I try to show you some motivating example, and then I'll talk about what if we don't have inheritance. In 2030, I didn't really emphasize so much about if you don't have inheritance, what kind of design principles would you violate? But now, this is a design course, so we should be more critical about alternative design. Okay, and let's do one step at a time, and then we have to review polymorphism, dynamic binding, and etc. Okay, that's the stuff we want to do. Okay, okay, that's good. For inheritance, there will be an aspect about code reuse. This is something I will also mention very quickly. It's just about how to use a corresponding keyword in IFO. You know all the concept about code reuse in Java already. That one's quite simple. However, the substitutability is about polymorphism and dynamic binding. We also need to make sure we review that properly. All the design patterns that we're going to talk about in about 1 or 2 weeks' time, they all rely on polymorphism and dynamic binding. So we want to make sure you're okay with it. And what's new is we talk about contracts intensively before the reading week. What does it really mean for precondition and postcondition, where you actually got A inherits from B? Do they inherit all the contracts? If they do, how exactly are they inherited? So there will be some theoretical issue we have to deal with, but that will come after the inheritance review. So these are all the aspects we expect you to know well before the exam. Okay, we'll go one step at a time. For today, we'll go a little bit lighter, but we want to talk about different design, so it's still interesting. All of you got a handouts, hopefully. Okay, if you haven't, feel free to pick up one copy here. Okay, try to be a little bit light, please. Okay. I want you to maybe spend about 1 minute or 2 minutes just to read a passage for me, okay? Just to understand what the problem is. And then we're going to use this as a working example for the rest of the lecture about inheritance. Okay?
But if you don't call result.compare objects in your edges method, then the starter code doesn't work for the lab 3 when you move your list graph over. I was stuck on that for like a bit, and then I'm like, wait, so you're checking has, but it's a different object, so it's not going to match.
Yeah. Yeah, take a look, and then think to yourself the following, right? On the exercise sheets, of course, you will know how to program this using inheritance in Java. However, do you really understand if we don't have inheritance, why would that not be a good design? That's something I want you to pick up today. Okay? Think about how many classes you need. Think about it. And then I will take some input from you. And then I'm going to present to you 3 potential designs for this problem here. One of them is about inheritance, but the other 2, not to use inheritance. And I'm pretty sure also you know, in general, if you are given some informal requirements, how do you identify classes and methods? Well, just very in general. Any noun potentially could be the candidate for class, attributes, or accessors. And any verb could be potentially some mutator, well, command, right? That's a general principle. Okay. Okay, I'll give you another minute just to at least familiarize yourself with the example here, and also the terms. Okay. And the reverse page actually talk about a little bit more when we assume we got inheritance, but we'll talk about it later today. Okay. Okay. What classes should we get? Let's say you don't have inheritance. What classes would you get? Can I say you for sure you need a class called course? Agree? For sure. Course, for sure. Course should be a class. Assuming that course class actually got an attribute called fee for a feature called fee. Course for sure. And what other classes do you need? Students? So now it's interesting. For students, as far as the requirement is concerned, you got to distinguish between either resident students or non-resident students. So now in this case, do you just want to have a single class called students, or you want to have 2 different classes? There's a design decision you have to make. Okay, so now it seems like we can have, well, we talk about without inheritance, right? So with inheritance, you pretty much know how it should work, but I just want to explain why without inheritance, you will violate design principle very badly. Okay, let's say without inheritance. Either you just have maybe a single student class, okay? And then, or that will be design. You know what? Let me be consistent with the number, okay? The first design we're gonna look at goes like this. Design number 1, okay? Let me just remind myself very quickly. Okay. Design number 1. Let's say we have one class called resident students. We have another class called non-resident students. That's design number 1. Apparently, you can see very easily what each class is supposed to do. And apparently, they have nothing to do with each other. No inheritance, right? And for design number 2. Okay. Design number 2. Let's say we have a single class called students. And I have a question for you. If we only have a single student class, how are we supposed to distinguish between resident students versus non-resident students? How are we supposed to? And attributes? Alan? Boolean? I agree. Something like this. Let me talk about this and I'll make it a little more general. For example, you can simply say is resident students, right? Is resident. And then that will simply just be of type Boolean. That'll be one of the attributes for this class. Of course, when it is true, that means this particular student instance is resident students. When it is false, that should be non-resident students. So we're using an attribute there to tell. To make it more general, I can make things like kind of students, because you should always account for extension to your projects. Maybe later on we have maybe 10 different kinds or 50 different kinds, depending, right? I think integer should be good, because we got 32 bits for the integer, right? Potentially you can get up to 2 to the 32. Well, I think that for sure will be more than enough. Okay, so that's a more general solution for design number 2. You got questions? You're fine. Okay, so these are the 2 designs we're going to discuss first without inheritance. And we want to be critical about them using the design principle we have seen so far. Okay, I'll show you concrete code. And the design principle I want you to think about, okay, I already also put exercise sheets. Number 1, think about cohesion. Number 2, think about single choice principle. And number 3, which is also very important, you can see at the very beginning we said we want to get a student management system, which means at the end of the day, we want to store maybe a collection of students. But given that each student might be of different kinds, how are we supposed to do it to account for this? Okay? So number 3 for the criterion would be, how can we get a collection of different kinds of students? So these are the criteria. Okay, for each design, we're going to see each one of them. And then eventually we'll see how inheritance can actually satisfy all of them. All right, is it clear for the roadmap? Jordan, questions?
Okay, I think you wanted to talk.
Oh, I'm going to talk about for sure. Yes, definitely. Okay, before I ask you to criticize on each one of them, I'll show you some concrete code so we have more basis for discussion. Okay, for design number 1 is actually on the slides. Okay. So for design number 1, we're going to see how we can have maybe 2 different classes which has nothing to do with each other. Okay? So you can see from the diagram over here, just no inheritance and no client supplier. So let's say, assume that we got a course class, let's assume. And we'll worry about the student management system class at the end. Okay? And then just have title, you have fee, and etc. Very conceivable. Let's say we got let's say we have one class called resident students. And remember in the requirements over there, what should be applicable for resident students? It should be premium rates, right? And also, you should also be able to register for courses and etc. Let's have a look. So let's say you have a constructor called make, and now you got name, you got courses, you got premium rates. Okay? So premium rate is only specific to resident students. And also we got a constructor which will create empty registered courses for the students. And then we also can set a premium rates specific to the resident students. And also we got register, which will just add a course. Let's say we don't have any constraint on how many courses the student can register. We might change that policy later, but for now it's okay. And also we got tuition, right? How do we calculate tuition for the student? Well, easy. You just add up all the amount or the fee for individual course the student have registered, and then multiply by premium rates. You can use a cross loop and then simply calculate the base, and then once you got a base, just multiply by premium rates. Okay, so that's your resident students class. Okay, that's the first design, part of it. Okay, I'll pause a little bit. Okay. Any question about part of the first design? Any question? Okay. My question is, if we want to complete the first design, how should the non-resident student class look like? Should it look very similar or look very different?
Very similar to the yellow class.
Oh yeah, actually, that's good. You realize that, right? So that's why I highlighted in yellow, right? The only thing you have to change would be just the yellow part. The yellow part somehow is specific to the class that we're talking about, okay? So now, if you go to the second class, non-resident students, right? Of course, the name has to be different. And then you got a constructor again. So now you can see we're repeating the name and courses. Disregarding the kind of student, they always should get name and also the registered course. That shouldn't change between kinds of students. But we got discount rate right now. It's a different attributes. And so we got constructor here. Also, we're repeating the code. And also, we got set discount rate. Again, that's specific to only this kind of students. We got register. Also, we got tuition. So now for the tuition, you can see part of it is being repeated because when you calculate the base, you still want to go over repeating the across loop just to calculate the aggregate amount. But what's difference is you're going to multiply by discount rate. So that's the second class, right? So far we have seen the details for this particular first design, right? We got resident students, we got non-resident students. No relationship between. Okay? And let's now talk about criticism for this particular class. Okay, first design, right? Any question about the coding itself, okay? There should be no surprise in terms of the syntax. Let's talk about cohesion. Do you think the principle of cohesion is obeyed in the first design? I heard yes, I heard no. Jordan, why would you think that's no?
So cohesive means only what should be in there is in there
Yes?
for each class, and so
Let's talk about how about resident students. What should not be there, but what's there?
so resident student should mostly contain only things that pertain to being a resident student.
I agree.
So,
Yes.
So anything that is just related to just being a student should be consolidated elsewhere.
Well, you're basically moving towards inheritance, right? So I'm just saying, considering the resident student as a self-contained class, is there anything over here? Okay, let me be more specific here. In order to judge cohesion, you have to go over basically every class that you're considering, for example, resident students, and now go over all the feature over here, okay? All the features over here. Is there a feature that shouldn't belong to the concept of a resident students? So what you just mentioned there, name, of course it makes sense for resident student because resident student should have a name. That's not a problem. And also every resident student should also get the list of courses they register. That's also fine. Okay? Guys, what about other features? Is there any feature that's in the resident student class that does not belong to the concept for resident students? Anything else? Seems like no. Okay, so everything that's in the resident students class, specifically you can see for the premium rates. So this is only specific to resident students. Whereas if you think about the discount rate, so this one is specific to non-resident students. It seems like each class individually is cohesive. The cohesion is indeed over there. Okay, so we're going to judge principle by principle. But it might violate some other principle, but we'll see that.
You could merge the discount rate and the premium rate principle, just change them. So you could call like balance modifier or something that modifies to either increase or rate of discount.
Just rate?
Just the rate
But you know, I would say,
modifier or something.
but still, I would say it might be Again, it's a design decision we have to judge, right? I'm just saying, for this particular one, maybe we just want to have a distinction between premium versus discount. Of course, I could have set another invariant to say the premium rate should be always larger than 1, right? And also discount rate in the non-resident student class should always be below 1. That's another thing I can say. But that could be one issue, but it's not the main issue. Okay. Any question about cohesion? So as far as cohesion is concerned, it seems like there's no issue for these two classes. Okay? What about single choice principle? So as far as the cohesion is concerned, I can put a check mark. Okay? Before I move on to this, okay, let's say single choice principle. Okay? Before I give you some hints, okay? How do we judge for single choice principle here? Okay, first of all, this code that's duplicated, for example, okay, you can see the register over here in resident students class is completely duplicated in non-resident students class. So you wouldn't be surprised if we want to introduce another kind of student, let's say maybe international students. In that case, their register method or feature will just be the same. So you're going to duplicate again. As soon as you see duplicates in your design or code, it's very likely you will violate single choice principle. Because if you want to change that particular common part, you have to change in multiple places. Exactly right. Okay, good? That's something we expect you to express yourself in the exam, right? So try to participate. Don't be shy to be wrong. That's fine. All right. Let's talk about the, let me be a little bit more precise here about single choice principle. Whenever you talk about single choice principle, right? First of all, you want to see if there's any duplicates. That's the first, the main thing you want to check. Any duplicates. If there are duplicates, and then you can think about what kind of changes I can make to my particular application of design. In this case, we can say, what if there's a new kind of students that's introduced? And also, what about if we change the registration policy? Okay, so let me talk about the first change. What if we introduce a new kind of student? Let me be more precise. Let me go back to this particular diagram I drew previously. Okay, so now let me just talk about at the abstract level. You can see currently for the registered students, I got a method or command called register, and there's another command here also called register. They are called the same name, and also the implementation is exactly the same, so they are duplicates. If I want to introduce another class over here, let's say maybe domestic students, right? In that case, I need to basically duplicate this particular register command verbatim. So that'll be another duplicate. So that's not good. That's one occurrence of violating the single choice principle. Okay? Another thing we can think about is, what if there's the second part? What if there's a change on the duplicated code? Let's say we now want to change our registration policy. Okay? You can see currently it's an unconditional registration for the student, right? If you want to add a course, we just add it. But there should be a cap, like how many courses you can register. Let's say, for example, if we want to say, if the current courses.count is already equal to 7. I'm not sure what the maximum is for you, but let's say 7. In that case, let me just make it better, just easier. If that's actually less than 7, so we haven't reached the cap just yet. In that case, you can go ahead and say courses.extend. And then extend the courses. Otherwise, you do maybe something else. Maybe to signal an error, something like that. Okay? If we want to impose this particular change on the policy, is this the only place we have to change? Not really, right? Because every occurrence of this duplicate, we have to change it. So that's a problem. So that means over here, this particular change also has to be duplicated into here as well. So again, the resulting code is still has duplicates, because every time you want to have duplicates, you want to maintain them, you just got to modify multiple places. Okay? So as far as the single choice principle is concerned, no. Okay? The first design is good for cohesion, but bad for single choice principle. Any question? Yes.
Say if we got rid of the register, and say register wasn't the feature of them, then
Uh-huh.
would it not? Then would it abide by single choice principle then? If we got rid of
Okay, so Ori's question was like this. Let me go even more extreme, okay? Let me just create a new one, okay? I see exactly what you meant. His question goes like this. Let me say, for now, let me get rid of all the duplicates for now, okay? So now let's say I'm going to get rid of, let's say, we don't have name. Name is also duplicated, right? It's declared twice in both classes. Also get rid of this, and also we even get rid of make, and also get rid of register, also even get rid of the common part, okay? Let me do the same for that. And also we get rid of this, and also we get rid of register, and also we get rid of the common part. Let's say, just for now. What's left over there is completely different between the two classes. But now, can I claim that they are not really violating the single choice principle? Maybe not, because the way things work is, you can see this class and this class over here, they're completely unrelated. And whenever you're judging your design, whether it satisfies a particular principle, you cannot just justify on their current states. You have to think about future changes. But now I can say, wow, I want to introduce a common registration policy for both students. Now, how would you do it? Since the two classes have nothing to do with each other, so the only way you can introduce a common registration policy to them would be you have to add a register over here that works one way. And then, because they are completely unrelated, so you also have to repeat the same register over here. So, for sure, it will violate single choice principle. So my main point is, even though the current design may not actually have the flavor of duplicates, but if you got the potential to introduce duplicates, it still violates that principle. You want to make sure it's right in the first place. Okay, so we'll talk about cohesion, we talk about single choice principle. Now the third thing is, okay, the third principle, third criterion we want to judge. How do you build a student management class accordingly? How do you do that? Well, apparently you want to create a class for sure, right? But now, is it possible to have a single, let's say, linked list of object type that's going to accommodate both resident students and non-resident students? I would say there is a way. I would say there's a way. Let me draw it here, okay? Let's say I'm going to have this particular class called, let's say, class student management system, okay? And then, how can I have a single linked list that's going to store all both possibility of resident students and non-resident students? Remember, these two classes are completely unrelated. How would you do it in Java? Let's say these two classes are unrelated. I want to store in a single collection only. Any idea? Linked list of, is doable. If it's not doable, just say it's not doable.
You could put any without imply that.
Yeah. So it's doable. In Java, it will simply say objects, right? Just any object in the list. So in here, I can say any, right? Any is like an object in Java. Let's say if I do that, is it good or bad? It's pretty bad. It's kind of the worst design you can have. But now let's see why. Easy to justify, right? Guys, you know, I'm really talking about design here, right? There's something, of course, it wouldn't apply just to IFO, but to Java, or C#, any other language. Can anybody explain to me why this particular design here? That's the good thing is now in the students, in a single linked list, maybe arbitrarily large, I can store both resident students and also non-resident students. Why is it bad? Why? Alan? That's one thing I agree with you. For example, that one has to do with static typing. Well, I'll just mention quickly. Okay, there's something even more fundamental than that. So let's say, for example, if I say I create some resident students, and then I got maybe rs dot make. Okay, let's say I got some object there. Okay, I got another one, creates non-resident students, just another different dynamic type. We'll talk about static type versus dynamic type more formally in a moment. Okay, non-resident students dot make. Okay, and let's say SMS is a student management system objects. Okay, I can say add rs into it. I can say SMS maybe dot add nrs into it. Let's say add itself also take any. Let's say, okay, just make it simple, because I can add anything into this particular linked list. So now what Alan said was a very fundamental question here. If I say now SMS dot students, I know that storing in the very first position is a resident students, right? Over here. I want to go to position 1. And then, first of all, I just say it's students. Of course, I can try to say register. Similarly, I also want to do also students over here at maybe position 1 again. Specifically, it's a resident students. I should be able to say set premium rates, and then maybe to be 2.3, for example. Okay, let's say this is 1, this is 2. Okay, what's wrong with 1 and 2? Or you can just tell me there's nothing wrong, that's fine. Okay, let's see if anybody, I'm pretty sure you know the answer. Should I point somebody? That's not so kind, right? Yeah. You know, don't be shy, you know. You rather think through this issue here rather than during the exam, right? Any thoughts? Ring. So you're saying that for 1 and 2, maybe you simply wouldn't compile. Okay, I agree. It can do cast for sure. Okay, we'll talk about casting and this kind of thing a little bit later. But it's for the following, if you really don't think it makes too much sense to you, there might be a little bit of gap between 2030 and in this course. Study a little bit harder for that. Okay, you would need it for design pattern. Okay, for line number 1 and line number 2, they simply will not compile, not even compile. The logic goes like this, but I will be a little bit more precise, maybe next Monday. Okay. For every student's member in the student's linked list, the any here is called a static type. Right? I'm pretty sure you heard about static type versus dynamic type in 2030. The static type for every member in the student class is simply any. So that means when you try to call this particular command over here, as far as the compiler is concerned, they will look at that and see it's of static type students. The only feature you can call on this particular expression is just the one that's defined in the student class. Oh, any class. I beg your pardon. Just confusing you too much. Let me say from the beginning. The static type is simply just any, right? So now as far as the compiler is concerned, the static type is simply just any. Now, is register a method or command in any? Not really. So you wouldn't simply compile. Just wouldn't compile. What you can do, as you learned from 2030, is do a casting. But doing casting for this kind of design is pretty bad. That means it will force you to do cast every time you want to retrieve something from the linked list. You want to do cast. Okay? That's one thing. Okay? I'll just mention that quickly. Another thing that's also pretty bad about this particular design goes like this. Because the linked list, you can store anything. It shouldn't stop you from storing anything other than resident student and non-resident students. Agree? I could potentially say SMS dot at maybe makes number 1, potentially. And then if I try to do it at the runtime to say, at this position, I want to register for mates, you can see nothing makes sense there. Okay, so know about this particular design, why it is bad. Okay. Okay, let me go back to the original thought. Okay, let's say for this particular design here, and then we got resident students and non-resident students. The only way we can really try to put them together is using the any type, but as I justify, it's pretty bad. So now it seems like we are forced to actually do 2 separate collections. Okay? Let me show it to you. Okay? And now, if you see, oh, everything's on the slides, right? I just thought it's actually more logical if I try to go like this. Let's say we got a student management system class. The only way that we can be more specific about each student type is I can say RS is a linked list of resident students. Okay? I got NRS, which is linked list of non-resident students. They are completely separate. Okay? But what's the disadvantage of that? That's a problem. Well, again, if you have this, the single choice principle problem will cascade to this level here. Why? Let's say this. If you want to have a command called register all, let's say for all the students, they should take a common course, maybe 3311. In that case, is it possible to use a single loop to actually do it? Not really, right? Because there are 2 separate linked lists over here. So there's no way to have a single loop that's actually going to register all the courses. In this case, you can see we're going to across the first collection, also across the second collection, and the rest, again, is duplicated. Okay? It's duplicated. Right? You can see that, again, it's violating single choice principle. Every time you got duplicates, again, violates that principle there. Any question about this first design? Okay? What you really want to do when you review this particular lecture, think about all the design we're going to talk about, and then to see why each criteria, maybe some of them satisfy some, but violates the others. Right? Okay. Any question about the first design? The second one is actually more interesting. Okay? The second one. Okay. Let's talk about the second design. And remember, the second design goes like this conceptually, right? Let's look at the second one. The second design, we are just going to have a single student. And now it seems like if we only have a single student class, how do we build the student management system class accordingly? It seems like the only one single linked list will be enough, right? You don't need to separate between several lists. So it seems like it's a better design. Seems like. But I can tell you, not quite. It's only improving maybe single choice principle, but it breaks other things. Okay? Let's see exactly how things go. So for the second design, the essence is we're going to have maybe an attribute here called kind to distinguish between the students. If you want to create a resident students, you'll set a kind to be 1. If you want to create non-resident students, you'll set a kind to be 2. Okay, that's how it goes. Okay, let me go back there and then go over the second design with you. For the second design here, okay, let's go over the design very quickly. This one is not on the slides, just on the iPad. So we have a class called students, okay? And then we have courses, we have premium rates, we also got discount rates. We put everything together, and also the kind is the one we talk about, right? Integer. So as far as storing the different kinds of students concerned, it's more than enough. You got 2 to the 32 possibilities, right? And then you can also try to, the constructor now has to be very specific to take a kind. Should it be 1? Should it be 2? Or it should be other number? Okay. Any question about the student class here for the second design? Okay. And now, how do we define get tuition and also register? Okay, it actually should just be called tuition. It's not get tuition. Okay. How do we define tuition and register accordingly? How do we do that? Basically, before we see the code, when you say you want to calculate the tuition, depending on what kind of student you're talking about, you may either want to apply the premium rates or you may want to apply the discount rate. Depends. So there will be some discrimination over here we have to encode into. Okay, let's take a look. And in general, for any command or query you want to define for this kind of application, you may have to suffer from the same problem. Let's see. Let's say just for tuition over here. So now we have a local variable, let's call tuition, just a real number. Okay, let's say. And then what we will do is, let's say you will first of all try to do a cross loop, so that'll be the common part. Just go across the courses and then add up all the base rate. You can think about that as a base rate. And then What the result should be now depends on what kind of student we are talking about. You would say either the kind is equal to 1 or the kind is equal to 2. Okay? And then if kind is equal to 1, we're going to multiply by premium rates. Otherwise, we're going to do discount rate. Okay? Let me go over the next feature. Let's say we also got register. Okay? Let me now change the policy a little bit. Since now we have different kinds of students, let's a little bit more fine-grained policy. Let's say for some reason, the maximum, the cap, the number of courses maximum the student can take depends on their kind. Okay? Let's say if it's a register students, they can take up to 6 courses, let's say, just for example. Let's say if the kind is non-resident students, they can take up to 4 courses. It's just different number. So that's why we have to distinguish. And then after this, we can now try to say if the current courses already reaches the maximum, you might do some error handling. Otherwise, you will extend the course. Okay? So these are the two commands. Also actually command and also query. Any question about the logic over here? Let's get the logic straight first. Make sure you understand how the design goes. And then we'll criticize using the 3 criteria. Any questions about this? All right. Go ahead.
So first, we made a feature for kind, right? Sorry.
Are you talking about tuition or
No, the student class.
the student class? Okay.
So with kind, we assign kind. So we pass an argument for 5.
Yeah, you got to pass the argument for kind. Maybe you pass 1. Okay, more precisely. Okay, think about how you might use this class. So you might say over here, I can say creates students over here. Let's say I have some variable, let's call rs. Let's say I wanted to create a resident students. What I would do is rs.make, and then I would say 1 over here. On the other hand, I can also say create students nrs.make. In that case, I'll pass 2. The idea would be for this design, once the number has been passed when you create the objects, everything else will depend on this particular number you assign to the objects, right? It should be fixed. Of course, if you want to change the kind of student, you can also do that. Let's not go that far. Okay. Okay, let's judge by principle. Cohesion. Is cohesion obeyed or violated in this design? I heard violated. Okay. Anybody want to explain why? Alan, first. Yeah.
Because like the student class has a bunch of features that might not be used by every student. So like, for example, rate.
Yeah. Very good. Exactly. So now you can see, for example, the fact that we actually got premium rate and discount rate, this will be a violation for cohesion. Somehow, well, it is true, students can either be using this or this. But for this particular application, we really want to distinguish between the 2 kinds of students. So now you're trying to mixing them in one single class. Oh, actually, of course, that's actually the rationale for having this particular design, because you want to support the kind in the same class, right? Okay, so this one here, so these are not belonging to the same kind of students. Not belonging to the same kind of students. So cohesion, not quite. Not quite. Okay. Any question about cohesion? Okay. Now, single choice principle. And let me, I want everybody to have a little bit more time to think about this, because this is really important thing to understand, especially the second issue. When you judge by single choice principle, we're going to talk about several design patterns after next week. One of the design patterns is called the state design pattern. That one there, we're going to compare non-OO approach versus OO approach to really see what's the essence between the two different paradigms. But this will be like a preview for that. Okay, I would say that's very fundamental. Okay, let me just make one remark for you, and then you can think a little bit more. You can think about this particular kind attribute over here really is how to simulate OO, like object orientation, using a non-OO language. For example, in 2031, you learn about a language called C. And C doesn't have the notion about classes or objects, right? If I say, now I want you to simulate OO in C, that's how you would do it. You may just define records, and then each record structure contains an attribute called kind. However, you will actually suffer from the same design flaw, like a design principle violation as well. Okay, I just want to, that's more like a remark. I will re-emphasize this a little bit later, okay? When you talk about that design pattern. Okay, so now, can anybody tell me if single choice principle is violated or not? This one is slightly different from the single choice principle case that we saw in the first design. How about this one here? Think about it. Do we have any duplication, first of all? Right, it's a simple question. Do we have any duplicates for code? I heard yes. Okay. If you say yes, where? Okay, you talk about the tuition? Okay. Anyone? This is really important to identify. Okay, maybe you're still organizing your thoughts. Yes.
But I think we do have to duplicate those.
Yeah, tell me exactly what the duplicates are.
Yeah, in register and tuition, you have to do kind every time.
It is correct. Somehow well, this one is a little bit different from before. What we are duplicating here is a control structure. More precisely, if kind equals 1, duplicate it, right? Similarly, else if kind equals 2, and else if kind equals 2. The control structure is duplicated, meaning that in order to distinguish between the kinds of students so we can do action accordingly, we have to do such conditionals in every feature. So this is a very important violation. You want to understand why it occurs. Okay? Okay, understanding that the green is duplicated and the orange is duplicated. So now, the next step, how do you judge the single choice principle is really violated? Second part. What kind of change can you make? Okay, I gave you a little bit hints. Okay, I gave you a little bit hints over here. Think about what if we are trying to define a new kind of students, number 1. Okay, and also, what about an existing kind of students obsolete? Let's say maybe the university policy decides we don't want to have premium students anymore. Oh, sorry, we don't have resident student anymore, let's say. Okay, something like that. So these are 2 possible changes. And each one of them can really demonstrate how single choice principle is violated, i.e., you will have to impose the change in multiple places. Any one of you want to help me out on the first one? Let's say I want to introduce a new kind of students, right? Currently, I have resident students. I have non-resident students. Currently, this is 1. This is 2. What would be the consequence if I want to extend my design so that I want to support another kind of student? Let's say, let me use a different color here. Let's say domestic student, and that should be number 3. So now, what should I do in order to make this new design sensible? Where should I go? Anybody? You want? Make another if statement. Give me one example. Where? Which feature should? Okay, iteration. You're saying the following. Because now we got a new kind of student called domestic students. So that means I may have to say over here, else if kind equals 3, and then I do something, right? Is that the only place I have to go? Not quite, right? Every place where I should distinguish between the kinds of student, I should do it. So that means the second place I should do it is over here, else if kind equals 3, and then I do something. Multiple places I need to modify, right? That's a violation of single choice principle. Jordan, any thoughts?
Well, the only thing about that is that if you're making a domestic student class, then you're going to have to implement that in each place anyway.
Exactly, yeah, exactly.
So it's,
Yeah, I'm just saying for this particular second design, because we decide we're going to use the kind as like an encoding of the student kind, exactly, right? And that's how exactly you would do it if you want to simulate Java in C. For those of you who might be interested taking compiler, for example, potentially you can compile your Java program into C code. But the problem is the C code doesn't support any classes, anything. So that would be the way to simulate. Anyway, that's an aside. Okay, given that we understand for the first change over here, when a new kind of student is introduced, okay, can anyone else can do a similar reasoning for me? What if I say an existing kind of student is obsolete? Let's say we want to cancel, let's say resident students. Let's say we want to cancel that. No more dormitory is supported, let's say. Would that violate single choice principle? Would that? Would it not? You want to try? Yes. You're not sure? All right. Gianna, please. Exactly right. So now, if a particular kind of student is becoming obsolete, let's say we want to cancel resident students, right? In order to cancel that, we have to say, for example, tuition, the resident students no longer applies. We're going to get rid of this, right? Also, similarly, I'll take a question. Similarly, for register, resident students also no longer apply. We're also going to delete this. So again, multiple places. So single choice principle violated. Question?
what if you don't? What if you just leave it there?
Okay, what if you don't? Then I think your code, your design is not even just a poor design, but potentially can have bug. How about, maybe put it this way. You should only put things that are applicable to your current application in your code only. If you simply leave them in that case, yeah, well, that's not good, of course, right? You shouldn't really leave anything that's not relevant to you, to your application in your code. Yeah. Yes? Oh, you're saying that it seems like, okay. You may be saying, is it possible to factor, okay, is it possible to maybe put the whole thing over here as a helper method? In general, no. Because what's really being duplicated, which is necessary, is to say if a particular kind is the case, else if a particular kind is the case, and else if, etc., right? Under each branch, you're going to do something maybe different, depending on the methods. In this particular get tuition, you're trying to do some calculation. Oh, sorry. In this particular get tuition over here, you're trying to do calculation of the tuition, right? On the other hand, in the branches over here, you're actually trying to set the maximum. So you just have different purposes. There's no way to have a single method that will simply just do the if conditional. It's just not possible. Mm-hmm. Questions? Say it again. Sorry, I couldn't hear you.
Take out max from the local variable and make it a global variable, and then just like make domestic
Okay.
whatever, and then set that. So you just
Sure. What you're saying is, no, that wouldn't solve the problem. I'll tell you why. You're basically saying, what you were suggesting is, why don't we make the max local variable over here to be maybe some global attribute over here, and then we'll simply handle that in the make. That might only work in the beginning. But what if I want to change the max later? Right? Once the object is created, I may want to keep changing the cap size for the kinds of students. In that case, it wouldn't work. Okay? What we're really talking about is for this particular design, for every operation you want to do on the objects, unavoidably, you have to distinguish between the kind of students. So simply by moving that kind of stuff into the global variable and handle that in the constructor, it's not going to work. Because constructor will only be handled in the very beginning when the object is created. But for other commands, they might also be called once the object is created. So it wouldn't work. Okay, any question about the second design here? Okay. Now, for the second design, how do we build the student management system accordingly? How do we do that? Actually, you know what? Let me make it a little bit more precise. In the first design, since resident students and non-resident students, they are not related to each other. So we had to create separate lists. In this case, do we have to? It doesn't seem like we have to, right? Okay. So it seems like we only need a single linked list of type students. It seems like, right? Let's take a look, and then we'll criticize that. Let's say we still got similar student management system class, okay? So student management system here, and then we can simply got students as a single element type for the linked list. That one's fine, okay? And then we can have add students, and then just add a student objects. That one's easy, just extend the students linked list. And then what's really the beauty about this particular design is when you say register all, and then you're going to say across all the students, only one single cross loop. And that's also one advantage of this design over the previous one. So you can simply say s.register. However, remember what we said before. The register command itself violates the single choice principle because that one there duplicates the if structure to distinguish between the kind of student, right? Remember, okay? Over here you can see the register over here, it has to repeat this particular structure to check the kind. Okay, just remember that. Okay, so now violates single choice principle. Okay, just to remind you. Okay, so now in order for me to write a client's code, okay, we'll get to inheritance very soon. Okay, let's say now I create a course, I create resident students, I create non-resident student. You can see they are of the same type. Okay, now how can I add a single resident student into SMS? How can I do it? How do I write a code? I would say, first of all, creates, right? Something I said already, creates. RS is of type students, right? I can say create RS dot make. And then I would say 1 over here, right? And also I would say creates NRS dot make. And then I'll put 2 here. And then I can now add RS and NRS into the SMS. And then I can call register all. At the runtime, this indeed will actually work. But the problem is, any method or command you want to call on this particular student, we know that itself violates the single choice principle. Wouldn't it be nice if we can somehow say we want to abandon this particular if statements? Which means, wouldn't it be nice if we can somehow not having to put this particular kind attributes? Is it possible? Okay, that's the only part we want to improve for the second design. Okay, now the answer will be inheritance. So what we really want to do is go to the third design for inheritance. Okay, before I go to inheritance for the third design, any question about the previous two? Any questions about this? Yes, Ori first.
Sorry, just to clarify, so the student management system violates the first principle because it calls features.
Yes, but basically the second design goes together with a student management system, students, and etc. Right? They're all together. Yeah. I'm just saying, if you only by looking at the student management system class, everything seems to be pretty good. You have only a single array holding all the students. But now, under the hood, when you call register or any other command or feature, you still have to distinguish between the kinds of students. You're repeating that structure. Yeah. So that's the imperfection about the second design. So that's why I said the conclusion would be, it would be very nice if we can keep the simple structure for the student management system here, namely just a single linked list. But we want to say we don't have to repeat this kind of if then else if structure. It would be very nice if you can do it. And the answer is inheritance. Yeah, I'll take the question.
So if for kind you had a tuple that a tuple and then like an array of tuples that gave that you could input like say if you wanted to add another like another type of student and that to
Are you okay? Let me just get it straight. You want to make some improvement to design number 2, am I right? Okay. Which class do you want to improve? Students or just student class, right?
Yeah.
What exactly do you want to do?
Because if you change kind with an array of tuples, then you can add like a value for the rate and for the max. Then you can set those before you actually like go. So like I got it when you said that it has to be a global variable. Like if you make them like max a global and
Okay. What you're saying is. What you're saying is over here, you want to predict exactly what are the range of values I might have to change at the runtime. In this case, tuition is one of them. By the way, it's a real number, right? Max is another value I might want to change at the runtime. By the way, it's integer, right? But in general, the thing I want to change for each individual command or query, they could be of different type. In that case, what should be the type of your array? Array of any? In that case, right? You think that array of any will be the only choice. So you're saying maybe, this is how I understood your design. Okay, I can tell you first of all, it's not going to work, but let me try to be a little bit more elaborate. Okay? So what you're saying is, you want to say values over here will be all the possible values you want to store for any kind of students. You want to set, let's say for this particular kind of student, I'm going to set it accordingly. Okay? Let's say over here. Let's say values is going to be maybe array of maybe any in this case. I tell you what the issue is over here, right? Let's say for this particular array, index 1 is going to store the real number. Okay? Index 2 is going to store the integer over here for this particular example, right?
If the array, so the index with the type of student, so instead of an integer, you have an index the like resident student and index.
Oh, that's what you meant. Okay.
And then inside you have a tuple that has all the values. Say the first one is a
I see what you mean. That's pretty clever. That's pretty, okay, now I understand what you mean. Okay. So what you're suggesting is like this. Okay, I'll just share that with everybody here. So what you're saying is, of course, you may have some variant to say the kind should be a valid index of the array, right? Yeah. Okay, I see what you mean. I tell you why it would be not so good. Okay, I'll tell you. Okay. In that case, what you have to do is, okay, maybe you have one array called max. It's going to be an array of, in this case, max will be of type integer. And then you have another array called tuition. And then an array of, and then real. Let's say, okay? The problem of this is, number one, you can see in this particular case, the max over here is supposed to be like a local variable over here. But now you're making that global. I'm just saying, you're forcing every particular value you want to calculate for the feature to become a global variable. But in some cases, maybe you don't want to. You're forcing everything to be global. That's not good. So you don't have that kind of encapsulation for the local variable. That's one issue. Okay? Number two, you're also making your code to be written not so intuitive. Right? Because what you have to write over here, you know what? How about this? I think it's a very interesting design. I would still want to get the inheritance quickly so everybody can know about the syntax. I will talk about this one specifically on Monday. I'll tell you what the drawback is. I'll try to prepare a little bit more coding here to show everybody. Okay? So this particular alternative design is very interesting. I will talk about it again next Monday. Okay? I'll prepare something extra. Okay? Okay? Let's now talk about inheritance quickly. Okay? And we spent so much time talking about the two designs before we talk about inheritance because those are important. Those really give you insight about how you can judge different design principles. So don't be too surprised. We gave you something similar and then ask you to criticize. and we expect to see your insight into the criticism. Okay. Okay. Let's now talk about inheritance quickly. Okay, everything has been talked about over here before the inheritance. So what I want to go for is inheritance. So that's how you draw the inheritance diagram for the bounds syntax. Of course, you got to use the right arrow. Let's look at the syntax quickly. Okay, let's see how much time I have. About 5 minutes. In order for you to declare inheritance class, so this is where I put all the common parts for all kinds of students. So now I can factor them out. So I don't have any duplicates. So that's how I resolve the single choice, how I obey the single choice principle. So I say I have a single class called students, and then name and courses, these are common for all kinds of students. I'll put them there. And then I have a constructor here, and they can also be reused. Okay? Everything you think should be shared among the descendants, they should be put here. And then you got a register. Okay? And that one should also be shared. Now, the tuition part is interesting. Part of it was duplicated in the first design, but part of it was not. So now how can we, in the inheritance case, how can we say that only this part should be inherited, whereas other part, I should add something additional to the individual kind of students? In Java, what you can do is you can use the keyword super, right? To say, I define some common code in my parent class, and now in the subclass, I try to call that using super keyword. I assume you know about the super keyword. But now, how do we do that in a different language? You just have to know the keyword. It's called precursor. Okay? Let's take a look. So let's calculate the base amount, first of all. You can still use the across loop. And then, so now you can see that's the whole class. Okay? So now, we're going to define the two subclasses that's going to inherit all the common parts. In addition, we're going to add something extra to each of the descending classes. Let's see, quickly. And especially want to show you the precursor. Let's say we got resident students here, and the idea would be we don't want to duplicate any common parts anymore. So resident students inherit students. So that's important here. So now these classes, they will be related to each other by inheritance. Okay, you're going to say redefine iteration. You'll see why we need to redefine it. Not just calculating the base amount, we want to calculate also for the premium rates. Okay, we say premium rate that's only specific to this particular resident student class. So cohesion can be obeyed. We're not creating anything that's not relevant to resident students. And notice that we don't have the attribute called kind over here. We don't need that anymore. Inheritance can handle that automatically for us at the runtime. And by the way, it's called dynamic binding that you learn in 2030. Well, we'll emphasize that again next week. Okay, set premium rate and tuition. So now you can see this is a keyword you may have to use later for your developments. So it's called precursor. So what a precursor means is I want to call the version of this particular query. In this case, it's going to return a real. So which version I'm going to call? The superclass. In that case, I'll just simply go back to the superclass and then call this particular tuition. Call that. Call that first. That's kind of common. And then after I have done that, I'm going to apply something extra that's specific to the resident students. Okay? Now, if you examine this particular class here, you can see, number one, there is no duplicates. So single choice principle is going to be obeyed. Okay? Number two, you can see we only store things that are relevant to resident student, like a line number 8, premium rates. Right? So cohesion is also fine. Let me show you final slides, and then we'll pause there. Okay, one final slides. And then if you look at the second class over here, non-resident students, so here also inherit from students. So they are siblings. And you can see we try to define something specific to this class, name and courses that are inherited. Okay? And then set discount rate, tuition, and now you're still using precursor. And then you simply apply the discount rate. Okay? Okay. Next Monday, make sure you bring this handout here. We're going to use the reverse side.